Right, Lyall's up next. So Lyall Wood from Wydeen School. Where are you, Lyall? Up you come, my friend. Up the steps just here. Now, if you ask Lyall what his favourite subject is, he's going to answer physics, but he's going to be a lot more specific. He's going to say quantum, particle, and atomic physics. 3 favourite subjects. And he also enjoys gaming and climbing, though I assume not at the same time. Although, again, that's Assassin's Creed, really, isn't it? Think about it. Anyway, please put your hands together for Lyall Wood.
Everything is made of atoms. Do you know who said that? Nobel-winning physicist Richard Feynman. But what actually is an atom? Well, not that long ago, we thought that atoms were indivisible. We thought there was nothing smaller than them. And then we were obviously wrong, because we now know that they have 3 main components: protons, neutrons, and electrons. But once again, most people thought that they were indivisible. But scientists are inquisitive. We kept on working, and you guessed it, we found what makes up some of those particles. We now know that protons and neutrons are made up of combinations of different types of quarks. But how do we know that? We can't just go to the back of your shed, pick out your biggest hammer, and smash up the particles that make up atoms. No, that's not how it works. Instead, we have to build massive racetracks. But they're not your standard Formula 1 Saturday night TV. No, these are much faster than Formula 1. Much, much faster. On our racetrack, we've got 2 lanes. And in these lanes, in this case, are positively charged protons, whizzing round a fraction away from the speed of light. As they whiz round, they get closer and closer to this infamous speed of light until we collide the 2 lanes and the particles smash together, releasing a great amount of energy. From that energy, we can get particles. Yes, I know it sounds pretty strange, magic, you know, energy turning into matter out of nowhere. But it works, applying the famous rule and law of the equation E equals mc squared. What that actually means is energy equals mass times the speed of light in a vacuum squared. It sounds a bit like gobbledygook, but if you divide energy by the speed of light in a vacuum squared, you get mass. The speed of light is obviously a very, very big number, so you don't get that much mass and you need a lot of energy. But with the great amount of energy we get in our huge racetracks, then we can find the strange and wonderful particles that do make up the fundamental building blocks of the fundamental building block of our universe. I just think that's pretty crazy. And throughout our lives, we've gone from thinking atoms are indivisible, and then people started to think, oh, well, if they're made up of protons, neutrons, electrons, they must be indivisible. And now we know about 2 up quarks and 1 down quark makes a proton, and 2 down quarks and 1 up quark makes a neutron. Well, I ask you, are quarks indivisible? And I haven't got much time left, so I just want to send you away with a question. No, not okay. I just want to send you away with a warning. And that warning is that you should never, under any circumstances, from personal experience, trust an atom, because they make up everything.
Thank you, Lyall. We've just had E equals mc squared explained on the stage, which I think is pretty awesome. Judges, who'd like to start the question? Jamie?
That was an extraordinary amount of detail in there, and to tackle quantum mechanics is no small feat. A mean question. Why do we care?
Why do we care? Well, I think the thing about it is there's so many things in science that we can use for other appliances, but quantum mechanics is something a bit different because, yes, in a way you could say it doesn't directly link with some things that we can do in our lives, but in fact, I don't know if you've heard of quantum computing. We're talking about computers that can work out your credit card details before you can say credit card details. I think that's pretty crazy.
brilliant, well done.
There you go. You gave a hard question and he smashed the answer. Brilliant. Do we have a follow-up? Sarah, yeah.
I'm interested that in some of your research, you watched some YouTube videos, I think, that explain some of this. So YouTube, force for good when learning about science, do you think?
Well, I think it's all about just trying to find what's good for you. But the thing I found that was good about the specific YouTube I watched is because I'm quite interested in getting my mind blown. I like finding out things that really surprise me. And that's why quantum physics is so great. And if you're just reading through all these long forums of all these, PhD physicists writing their papers, it gets a bit confusing for a year 9 mind. So YouTube can simplify it into a few minutes, and you learn just as much, if you know what I mean.
I agree.
Yes, indeed. There's some great stuff on YouTube, I tell you. Right, let's have a huge round of applause for Lyall. Thank you.